Okay, this is the solution for test 2, problem number 3, where you have a wire that's bent into a semicircular shape with 2 straight portions. And part A asks you to determine the magnetic field at the observation location X here. So for this, since the conventional current here and here is parallel, it doesn't contribute, so you'll only have to consider this conventional current. And using the right hand rule, aligning your thumb with the conventional current and curling your fingers, you can see that the direction of the magnetic field is into the page, or the negative Z direction. So moving on to part B, it asks you to write an expression for a small portion of the magnetic field of the wire at the observation location in terms of giving variables and known constants. So we'll start with our generic formula for finding the magnetic field. So the most complicated portion of this formula is probably the cross product, so we'll start with that. And using the formula for cross product, you have delta L magnitude times r hat sine theta. So that is going to make delta L equal to r delta theta, which represents one small piece of your length. So plugging that into our formula for delta B, you get this expression, and remember, since we've already determined it's in the negative Z direction, we have a negative sign here. And R is our observation distance, which is not changing at all because it's this circle. So this just simply reduces and the r's cancel and you get this expression. Okay. So moving on to part C, we're asked to integrate, and you have, this is what it's given you, so it's only a half of a circle, so you go from 0 to pi instead of 0 to 2 pi. And we're just going to copy down our old expression. And the variable that we're integrating here is theta, so everything else is constant, can be moved outside of the integral. And when you plug everything in, you'll get a theta here from your delta theta integrated from pi to 0, so you'll get pi from that portion, giving you this. So your pi's will cancel, and your final answer is this. And lastly, part D says, what is the magnetic field at your observation location due to the straight wire? And we kind of already mentioned this in part A, but at the straight wire, at the observation location due to the straight wire is 0. And this is due to the curling nature of the magnetic field. If it's in the same line, it does not contribute. So magnetic field is going to equal 0.